And one of the big mistakes when students take the derivative of this, let me see if it's on the next page. No, it's not. Okay, one of the mistakes students make when they take the derivative of this is they do the chain rule right away. And what do I mean by that? They'll say 3 times x squared, and this is wrong, but let me just do it. 3 times x squared, they'll carry down the inside, they'll take the power down by 1, and then take the derivative of the inside. Okay, so they'll do something like this. Okay, why could I not take 3 times x squared? Yes, because this has an x. When you do chain rule, and I probably didn't clarify this, but when you do chain rule, 3 can only be multiplied by a number. Does that make sense? It can't be multiplied by x when you do chain rule, okay? So this has 2 x expressions, one here and one here. So it's not actually dominated by the chain rule. The dominating, operation here are 2 things being multiplied together because there are 2 x expressions. So instead of chain rule, which rule is this? Product rule. So let's do it. The derivative of this will be the derivative of the first times the second plus the derivative of the second. Now we got to slow down. What's the derivative of the second? Chain rule. So that's going to be 3 times, but do you see, this does have a number in front. It's 1. Okay, we don't talk about it, but it's 1. It's kind of like that uncle you never talk about. So 3 times 1. Carry down the inside. Okay, take the power down by 1. Okay, guys, leave the inside alone. What does that mean, leave the inside alone? It means leave it alone, okay? And then multiply by the derivative of the inside. What's the derivative of 2x plus 3? 2, okay? So let's see if we did this right. The derivative of the first times the second plus the derivative of the second, oops, what did I forget? Times the first, very good, okay. So this would be a good answer. It's just that your test is actually multiple choice. And although you like it, I just want to tell you, you guys actually do better on free response tests because this right here, you're going to have to match the right one and they're going to combine terms and such, right? So this would be 3 times 2 times x. Do you see all those monomials? You're going to multiply them all together. So you'll have 6x squared times the quantity 2x plus 3 squared. Okay, any questions on chain rule? All right, let's go ahead and, talk about cheers. So today, what we're gonna talk about, can you guys pull out your formula sheet? We're gonna add some formulas to your repertoire, okay? Your repertoire is all the formulas that you have memorized, okay? Which will be this yellow sheet by the time you're done, okay? For your test, you cannot use your formula sheet, so make sure you know all of your formulas, okay? Our new formula today, go find derivative of EU if you can find it, okay? The derivative of EU is EU times the derivative of U. So EU times du dx. Okay, so write that down. Some people, like every once in a while, I'll see EU times U prime, which is exactly the same thing. Okay, but I usually just use du dx. Raised to the square root of x. Okay, sometimes, guys, as we do these problems, we're going to have to rewrite them. Okay, and so it's really hard to take the derivative of square root of x. But guess what? You can rewrite this as x to the 1/2. Okay, you guys good with that? And so just make sure you know how to rewrite these problems. For example, if you had x cubed root of x, what would you rewrite that as? 1/3. What if you had x squared on the bottom? How could you rewrite that? X squared on the bottom. X to the -2. You guys good with that? So sometimes you'll get stuck because you'll be like, I don't know how to take the derivative. You just rewrite it. This one you'll see again pretty soon. But this one is actually a little bit difficult. How could you rewrite 1/4x to make it so that you could take the derivative a little bit easier? Close. Don't move the 4 up, right? Because the 4 doesn't have a problem, right? It's the x that has a problem. So what you want to do is leave the 1/4, but move the x to the -1. Okay? All right, let's look at this. If I had the 5th root of x to the 4, do you guys understand that the root is always the denominator, okay? The power is always the top. So this would not be 5/4, but it would be 4/5, okay? And then finally, if you have 2 bases that are the same and you're dividing, what you do is you subtract these exponents. So this would be x to the -1. Guys, what would you have if you had this? What's x to the fourth times x to the fifth, what would you have? Okay, what about this? What if I had x to the negative 4 times x to the 4? What would that mean? Oh, that was sharp. Okay, yeah, this is x to the 0, which is 1. Okay, but another way to think about that is this right here, make it 1 to the x to the 4, right? Times x to the 4. And wouldn't that also be 1? Okay, so lots of different ways to think about this. Okay, I want to talk a little bit about e to the x, and we've talked about e to the x and ln of x before, but I want to make sure you guys understand. If you graph e to the x, it looks like this. Do you have that memorized? Okay, is this in your notes by any chance? Yes, okay. This point here is something you need to memorize. If you plug in x equals 0, guess what your y is here? 1, it is. Okay, remember e to the x is the inverse of ln of x. Okay, so this is ln of x. So if you have a 0.01 here, then ln of x has a 0.10. Okay, what if I shifted this with +3? Left or right? Or up or down? You go up 3. Okay, everybody good? This is up 3. If you shifted left or right, it would be this. Does that make sense? This would be a right shift, and this would be a left shift. Okay, right here though, this is just adding 3. So this point, this would be e to the x plus 3. Okay, and right here, guys, what would this point be in? Very good, 0, 4. And you could plug it in and make sure. So for example, if I plugged in 0 here, what's e to the 0? 1. And do you see how you get the 4 there? Okay. What if I had to draw e to the negative something? Okay, e to the negative x or e to the negative 2x. You have to know that that just flips this graph over the y-axis. Okay, so it looks exactly the same, but it's flipped on the y-axis. What do you think this point is here if I plugged in 0? It is. It's actually 1. So it's kind of weird. But since you plug in 0 here, the exponent is going to be multiplied by any number. It's going to make this 0. So this is always going to be e1, which is kind of interesting. Okay, I want you to notice something about not this graph, but e to the x and e to the negative 2x. One thing you have to know about it is that it's always positive. Do you guys see that? Like if I have e to the x and I put in positive or negative numbers, like let's say I put in e to negative 3, that's still a positive number, right? Even though the exponent is negative, it is still a positive number, okay? It's kind of like one of those, what do you call it, oxymorons or like weird things about life, you know what I mean? Okay, so if I plugged in here 3, okay, if I plugged in 3 here, do you see that this point would be e to the negative 6? But e to the negative 6 is positive. Did you know that? Isn't that weird? Because that's really 1 over e to the 6. And even though it has a negative exponent, it is a positive number. Okay, we're good on that? All right, so let's go move on to taking some derivatives. Okay. Just a reminder, they're really only, besides your log properties, because you know your log properties, right? 1 log fraction equals 2 log subtraction, and 1 log multiplication equals 2 log what? Summation. Okay, besides those formulas, you need to know the 2 derivative formulas that we've learned already. So the first one is log u is equal to u prime over u. Okay, and sometimes it's easier this way. All right, and the other one that you've memorized is log AU. And if you haven't memorized it, you should go ahead and memorize it. It's u prime over u. It's the exact same, but you have just this extra ln of a, okay? And again, that's the same as 1 over u ln of a times du dx. Okay, you've already memorized those formulas. What we're gonna add on today is the derivative of e to the x, oops, e to the u, sorry, not e to the x. E to the u is equal to e to the u times the derivative of the exponent, okay? And I think you'll find this quite refreshing, at least compared to what we've been doing. All right, so what would the derivative of e to the x be? Okay, so y prime would be, the formula is e to the u du dx. So you copy the e to the u, then you multiply by the derivative of x. What's the derivative of x? 1, and so that's e to the x. So what would the derivative of e to the 2x be? First, you copy the e to the u, then you multiply by the derivative of 2x, which is 2. Do you see how easy this is? All right, and I'm going to rewrite it. Huh? Yeah, I'm going to rewrite it, but you don't have to. But remember, if we're a multiple choice, it's more likely like this. All right, what would the derivative of this be? A big number. Well, first you copy it, then you multiply it by the derivative, which is 2x plus 5. Okay, and if this were a multiple choice, it's way more likely that this 2x plus 5 would be in the front. Okay, it does need to be in parentheses because it's not just being multiplied. Well, if we're at the end, I think it'd be okay, but at the beginning, it's not 5e, it's 2x plus 5 quantity times the e. All right, and then right here, e sine x, if you took the derivative of that, it looks hard, but it's not. First, you do what? First, you copy it. Then you take the derivative of sine. You multiply by the derivative of sine. What is a derivative of sine? Cosine. Okay, so this would be cosine x. And then you probably would see it like this more so than you would see it like that, but they're both the same thing. Okay, let's move to a little bit more difficult problems, okay? What if you had a 2 in the front? Yeah, you just leave it there, okay? So 2 times e to the x would be 2 times the derivative of e to the x, which would be e to the x times the derivative of x, which is 1, which is 2e to the x, okay? I'm going to skip this one for now. What if I had this problem here? 2 times this e to the u would be, you guys, okay, first I write down the 2, right? Kind of pull it out because it's a scalar. Now make sure you understand, if it had an x in it, I can't pull it out, right? If I had an x, it'd be a product rule, okay? But it doesn't have an x, so it's a scalar. I pull it out, I take the derivative of this, which is e to the negative 3x plus 5. You just copy it. Then you multiply by the derivative of your exponent. What's the derivative of negative 3x plus 5? Okay, and then I'm going to simplify this. When I simplify this, do you see the 2 and the negative 3 are like monomials, okay? And they can be multiplied together. And so now you have negative 6, okay? All right, ex tangent x. How would I do this problem? Do you see that it's, yeah, do you see that it's 2 expressions with an x, right? So it's going to be product rule. Okay, so y prime. It's going to be the derivative of the first. Well, what's the derivative of e to the x? E to the x. The derivative of the first times the second, okay, plus the derivative of the second. What's the derivative of tangent x? Secant squared x. You guys need to have this memorized for the test. So secant squared x times the first, e to the x, okay? And that is your answer. The only one thing I would warn you about is this e to the x cannot be multiplied by this x because the x belongs to the secant squared family, okay? We don't break up families in calculus. And you don't break it up in real life either, but you don't break up in calculus either. Okay, actually calculus is real life. Okay, right here, guys, how would I do this problem? What rule is dominating here? Quotient rule. You guys ready? Here we go, f prime. It's going to be the derivative of the first. What's the derivative of 4? 0. Times the second. Now make sure you understand, the second is this whole thing here. So 0 times this whole quantity. So derivative of the first times the second minus the derivative of the second. Okay, so how do I take the derivative of this? Do you see it's just 2 problems? It's 2 separate problems, right? So the derivative of e to the x is e to the x times 1, right? The derivative of e to the negative x, let me just put down the plus sign, is e to the negative x. You copy it, and then you multiply by the derivative of negative x, which is negative 1. So derivative of the first times the second minus derivative of the second times the first, all over, it's all over, guys. Okay, the whole bottom quantity squared. Okay, I'm going to go through and try to simplify this. 0 times anything is 0, right? You still have this negative sign though. So this is really negative 1 times 4. Everything's being multiplied. So on the top you have negative 4 times e to the x minus e to the negative x. Okay, you divide that by the quantity e to the x plus e to the negative x quantity squared. Okay, when you look at this, you're going to think you can simplify this, but I want to point out this is a minus sign and this is a plus sign, so they're not going to be simplifiable. Okay, that's your word for today. Okay, everybody good? Yes, Emily? Okay, yeah, let me know if I did something wrong. Okay, you guys good? All right, let's move on. This problem here, this problem gives people headaches. Okay, what is this problem here? E to the negative 4x. I want to take the derivative of this. Okay, you agree, it's just e to the u, right? You copy it. But then you need to multiply by the derivative of this. What is the derivative of negative 4 over x? Yeah, bring the x up. Does that make sense? I mean, you could do quotient rule, okay? But it's a lot more work than if you bring the x up. What happens if you bring the x up? What does it become? Okay, can you take the derivative of that? Yeah, it's easier. Negative 1 times negative 4 is 4. X, take the power down by 1, negative 2. You see it? And of course, if you did quotient rule, you'll get the same thing. Do you want to do quotient rule with me? No, you're good. Okay. All right. I'll try not to be offended. Okay, guys, if you look at this problem here, you're not going to find it in a multiple choice. So let me simplify it for you. And you guys tell me if you can see that this would actually be a multiple choice answer, right? All negative exponents are not considered simplified. So if I move it to the bottom, it becomes a positive exponent. Okay? Maddie, your eyes are open? Okay. All right, this problem here. I want to take the derivative of ln. If you take the derivative of ln, what's the formula? The derivative of ln u is equal to what? U prime over u. Okay, so you guys agree this is my u, right? What's u prime? What's the derivative of this? Well, okay, first you copy it, then you multiply it by what? By the derivative of the exponent. Everybody good? So that's the top. That's u prime. You guys with me so far? Okay, what's my u going to be? Because that's on the bottom. What's my u? You guys good? U prime over u. Do you guys see anything that simplifies? Yeah, these e to the u simplify. So this answer, which is kind of interesting, is just negative 8x7 minus 7. Negative 8x minus 7. Like all the e's are gone. How did that happen? Did anybody see another way to do this? Do you see it, Caroline? Yeah, do you see why? Because what is, did you see you logged a tree? Yeah, what happens when you log a tree? The cat falls out, okay? So there's the cat right here. I hope everybody here likes cats. Okay, so right here, the cat falls out. But guys, don't forget, a lot of students will do this and they'll say this is the answer, okay? You gotta zip the cat's pants. You got it? You haven't done any calculus yet. All you did was a cat fell out of the tree, okay? You gotta take the derivative of that and you actually get the same answer, okay? So either or, but just make sure you actually zip your pants. Okay, let's look at this problem here. Chain rule, let's do it, okay? 4 times, do you see there's actually a 1 here? So 4 times 1 is 4. Leave the inside alone, take the power down by 1. What does leave the inside alone mean? It means leave it alone, okay? I always tell my daughter, okay, leave your little brother alone. What do I mean by that? Leave him alone, okay? So don't touch him, leave it alone, and then take the derivative of the inside. What's the derivative of this inside? Well, what's the derivative of e to the negative x? E to the negative x times what? Times negative 1, okay? Then I'm just going to carry down the plus sign. What's the derivative of e to the x? Yeah, it is. I'm kind of taking it in steps. The derivative of e to the x is e to the x times 1. You guys good with that? Okay, so there I am. It's the derivative. This is a chain rule. I'm going to simplify this. So this is 4 times e to the negative x plus e to the x raised to the third power times, this is really just negative e to the negative x plus e to the x. And at first glance, it looks like you can combine this, but be careful. This one has a negative and this one doesn't. Okay, so you have to just leave it like that. All right, any questions about that? Some people would. Yeah, you're saying like switch these? Yeah, some people would do that. Oh, move this whole thing to right here. I don't think it matters. It could be either way. Yeah. Okay. This I don't think is in your notes, but we've done this before. I just want to do a quick review before we get into our application problem to make sure we can do this. Okay. What's e to the 0? Okay. What's e to the -1? Or another way to write this, 1 over e to the 1. You guys good with that? Which is really 1 over e, right? Okay. What's another way to write negative e to the -1 then? How are these different? You just have a negative on the outside, okay? What about 1 over e squared? What's another way to rewrite that? Okay. What about ln of e? It's actually 1. Why? Because when you log a tree, what happens? The cat falls out. But what is the cat's name here? 1. Okay, everyone's going to name their cat 1 this year. Okay. All right. And then ln of 1 over e, what's that? It's -1. You guys do you see where it's -1? Okay, because this is really e to the -1. All right, what about this one then? -2. Everybody good so far? All right, let's go to an application problem. Okay, what if I wanted to find the minimum value of f? Okay, and I've got the function x e to the x. Okay, and I have no calculator, so I'm going to use calculus to figure out what the minimum value is. Okay, everybody good? If you want to find the minimum, it's really the absolute minimum. Okay, and the way to find an absolute minimum is you do a candidates test. You put this x on one side, you put the f of x on the other side, you put in your endpoints, you put in your critical points, and you choose the smallest number. Everybody good with that? But guys, did you notice I have no endpoints here? Okay, if you have no endpoints, okay, do the first derivatives test. Okay, and if you only have one critical point, then that will be your absolute max or your absolute min. Okay, probably that's going to happen if they don't have endpoints for you. So let's go ahead and do the first derivatives test. And anyway, even if you were doing the candidates test, you still need your critical points. So you still need the first derivative. So, and you know what, actually, even if you didn't know what to do, we are doing calculus in here, right? So if you're clueless, just take the first derivative. Maybe you'll get some partial credit, okay? So we're going to take the first derivative. It'll be, do you guys see this is product rule? It'll be the derivative of the first times the second plus the derivative of the second. The derivative of e to the x is e to the x times 1 times the first. Is everybody with me so far? Okay, so the first derivative is e to the x plus e to the xx is equal to 0. And e to the x plus e to the xx is equal to d and e, right? We're trying to find the critical points. Critical points happen when f prime is equal to 0 or d and e. Okay, I'm going to solve for x here. That's going to be critical points. Solve for x here. That's going to be critical points. Everybody good with that? I'm going to put all my numbers into an f prime number line. Okay, this is what we've done over and over again. All right, so let's solve on the left here. How can I solve for x here? Yes, well, not combine them, actually pull it out. Does that make sense? Because if I can get something times something equals 0, then one of those somethings is 0. Okay, so do you see both terms have an ex? So if I pull out ex, do you see I have 1 plus x left? Do you guys see how I did that? Okay, so guys, if I get something times something equals 0, what does that mean about one of these somethings? Okay, so e to the x is equal to 0, or 1 plus x is equal to 0. So I've got one critical point so far. You know, I can put that into my number line. Okay, over here, e to the x is equal to 0. How do I pull that x out? Okay, if the opposite of e is logging, so I've got to log this tree. But you can't just log one side of the tree. You got to log both, right, to make it equal. Okay, so if I log this tree, the cat falls out. What is the cat on this side? X. Okay, on this side, you see there's no e, so you're not logging any tree on this side. This side is just ln of 0. Is everybody good so far? What is ln of 0? Think about the ln graph. This is what ln looks like. Well, ln of 1 is 0. ln of 1 is 0, but what's ln of 0? If I plug in 0, what do I get? It doesn't exist, okay? And if you're not sure why, go put it in the calculator, okay? And watch your calculator freak out. Just do ln of 0 and you won't get anything, okay? The other, so this actually doesn't give us a good answer, but look at this. E to the x equals 0. Remember what we said about e to the x? What does the e to the x graph look like? Does it ever touch 0? No. So same thing. Neither of these exist. Okay, there's no x where that happens. So nothing good comes out of that. All right, let's look at this one with D and E. Okay, what x value would I plug in here that would cause this to have a problem? Actually, even negative numbers would be fine. Watch. Right? Nothing. So there's no critical points generated from over here either. Okay, so I only have one critical point, which is actually kind of nice, and I'll show you why. Because let me pick up some terms on this side, some numbers on this side, and some numbers on this side. I'm going to figure out plus, 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 or minus, minus, minus. You remember doing this? Okay, what's a good number to the left of -1? A good number to the right of -1? 212, thank you. Okay, so then what we're going to do is we're going to come over here, we're going to plug into f prime, okay? Where is f prime? Okay, I think this is the easiest one to plug into just because all I need to know is positive or negative. So let me plug in -2. That would be e to the -2 times 1 plus -2, which is -2. Okay, I just need to know positive or negative. 1 minus 2, do you agree, is -1? So that's negative. Okay, e to the -2. Here's a trick question. Is this a positive number or a negative number? It's positive. It looks negative, okay, but it's actually positive, okay? So this is going to be negative on this side. All right, on the right side, we're going to plug in 212. So this will be e to the 212 times 1 plus 212. Okay, I just need to know positive or negative. 1 plus 212 is positive. What about e to the 212? Positive. So positive times positive will give me positive. Well, if f prime is negative, f is decreasing. If f prime is positive, f is increasing. Do you remember this? So what does my f look like? My f looks like a parabola, so to speak. I mean, it's not a parabola, but it looks like a parabola. What is my lowest point on that parabola? -1. Okay, so there's a rule, and we talked about this before. I'm not going to make you do this justification, but you need to understand this justification. When you have only one critical point, and on the left, f prime is negative, meaning f is always decreasing, and on the right, f prime is positive, meaning f is always increasing, then this point is your absolute min, okay? And so guys, if they asked you to find the minimum value of f, is the answer -1? What is the minimum value of f? That's where the x is. Does that make sense? That's where the minimum value is at. The minimum is at x equals -1. What is the minimum value? What number am I actually looking for? The y. You're really looking for the f of x, okay? So what you have to do is plug in your f of x right here. Okay, plug in -1. Why don't I plug into the derivative? Why don't I plug into the derivative? Yeah, because you're trying to find the minimum value on f. Does that make sense? Guys, if you plug -1 into the derivative, you should try it. You should get 0. Because actually I set it equal to 0. Does that make sense? To find x. So you'll get 0. But let me plug it here into f. So that's -1 times e to the -1. Do you see that that is -1? Well, that's really negative e to the -1, which is a great answer. Another great answer would be -1 over e. Okay? Are you guys good on this? All right. And then there's one more thing I want to talk to you guys about. And that is your favorite subject, the definition of a derivative. Okay? Whenever you see the limit as h goes to 0, in your mind, you should be saying, I know that formula. Actually, it should be on the front of your formula sheet if it's not already. If it's not already, please make sure you put it on. We did spend some time putting it on. Okay? But the definition of a derivative, anytime you see this, you should say, oh, you know what? That is equal to the definition of a derivative. So if they're asking you what this is, all you need to do is find the derivative. But guys, to find the derivative of f, you need to know what f is. Does that make sense? Okay, so what is f? Well, look at this formula. This is f of x plus h. There's your minus sign right here. This is f of x. That's f of x, okay? That's h. Guys, what is my f of x? E to the x. So on the side of your paper, you should say f of x is e to the x. I need to find f prime of x. So f prime of x is what? What's the derivative of e to the x? E to the x times 1, which is e to the x, and that is your answer. Does that make sense, guys? Okay, so that's how you do that problem. I think you are armed and dangerous for your homework, so you guys can do the first page that you guys picked up here. It's just 1 page long. The back side is your homework for tomorrow. Your first problem says find the equation of a tangent line. Do you see that? What 2 things do you need for that? A point and a slope. Okay. What point did they give you on number 1? Okay. What slope did they give you? Oh, did they give you a slope? No. How do you find the slope of a tangent line? The slope of a tangent line. When I say derivative, you say slope of a tangent line. So guys, this is just the derivative. You're going to take the derivative of f, but be careful. You need to get into a number. So once you take the derivative, what is it? Is it e to the 3x or something like that? Okay, what's the derivative of e to the 3x? 3e to the 3x. Okay, that's the slope, but you need this a number here. Okay, so how can you change this to a number? Yes, you know your x is 0 and you know your y is 1. So this is 3e to the 3 times 0, which is 0. Now be careful. A lot of students would take this and say this is equal to 0. Okay, yeah, it's not equal to 0. What's e to the 0, guys? 1. So this is actually 3 times 1, which is 3. Okay, and so guys, you guys do it. Write the equation of a tangent line. See if you can do it. You got all numbers now. You just need to plug it in. So it'll be y minus y is equal to the slope, should be all numbers, times x minus x. Okay, this is a great answer, but if it were a multiple choice, it's more likely that you'll have this as your answer. Okay. Okay, looking at your homework from last night, what questions did you guys have on it? Okay, tell me. What questions did you have? Go ahead and pull out your homework too, because I'd like to check it for today. Those of you guys online, did you guys have any problems that you guys wanted to see done? Online, guys? You guys are totally good? Okay, let me know, guys, if you guys want anything online. All right, so 15, guys, on your homework from last night. Can I see what that is? So 15, oh, I like this problem. You might see a problem similar to this. I don't know, let's say maybe Tuesday. Okay, so guys, if you want to take the derivative of an ln, okay, do you agree that that would just be u prime over u? You know the formula, right? The derivative of an ln is u prime over u. Well, what's your u? Your u is just whatever is to the right of your ln. This is your u. Okay, so to do this, you would take the derivative of this and divide by this. Everybody good with that? Well, what's the derivative of this? Isn't that product rule? Okay, and then you divide by u. Okay, so let me just, I'll do that, but I want to show you there's an easier way to do it, but I'll do it. So this is going to be the derivative of this. Yeah, oh, wait, I hear something. Okay, one log multiplication equals what? 2 log summation. Okay, so I'm not going to do that stomachache thing. I'm going to go ahead and change this to, maybe I want to change this to just y. Okay, so y is equal to that. So now y is equal to 1 log multiplication equals 2 log summation. You guys good with that? Okay, but guys, I haven't even taken the derivative yet. Make sure you guys understand. The 1 log multiplication, 2 log summation thing, that's just log properties. It's algebra 2, okay? Let's go ahead and zip our pants here. What's y prime gonna be? This is u, so what's u prime over u? 4t cubed, do you see where I'm getting u prime? Over t4 minus 2, plus what? U prime over u, there's your u. 3t squared over t cubed plus 1. Guys, I need to make sure you understand something. When you take the derivative of an ln, do you see you do not carry the ln down? Is everybody good with that? That's what students do. They'll carry the ln down, then they have a giant ln problem. Then they're like, wait, this is even worse than what I started out with, okay? This is actually your answer. No logs should be in your derivative, okay? What other questions do you guys have? Yes, Eric? Oh, I don't know. This is a multiple choice? It's D as in dog with us. Yeah, but I think you don't have to actually multiply it out, right? You just create a common denominator. And then, so your common denominator will be t to the 4 minus 2 times t cubed plus 1, right? That means here, you're going to have to multiply by t cubed plus 1 times t cubed plus 1, right? And over here, you need to multiply by t4 minus 2 and t4 minus 2. And actually, if you look at this carefully, you can see that this is in one of those answers. Does that make sense? One of your answers has 4t cubed times t cubed plus 1 and 3t squared times t4 minus 2. Okay, what other questions do you guys have? And guys, this is actually, I feel like this is going to be the hardest thing about this multiple choice test, because you're going to be looking at answers, trying to figure out algebraic. Which one is right? All right. Okay, what other questions do you guys have? Okay, guys, let's look at number 12. No, they're not there. That's okay. Most of the time, they're not there anyway. Let me see. Okay, we're looking at number 12. I can see my screen here. Do you guys see my screen down here? It's just not showing on the Promethean board yet. So let me just go ahead and write your problem. Actually, maybe oh, there it is. Maybe I have it here. Number 12. Is Zoom back on? Oh, do I actually have to turn it on? Oh, let me see. Where are these guys? Oh, they're right there. Hey, you guys, wait, can you hear me? You can. Okay, let me go ahead and share my screen, guys. We had a big power blink over here. No fire or anything, thank God. We're okay. Just in case you were wondering. But it was kind of dark over here. I'm sharing my screen, but you're not bouncing over to the other side, which is kind of strange. You usually bounce over to the other side when I share my screen. Am I sharing my screen? Can you guys see my screen? Yes? Okay, good. Thank you. Yeah, but they usually bounce to the other side when I share my screen, so I'm not sure what's wrong. Okay, number 12. Someone asked about number 12, guys. We're going to take the derivative of this. Okay, this one is very similar to the one that we just did. Okay, this right here is 1 minus 2x squared. Okay, we're going to take the derivative of this. So we're looking at number 12 on your homework from last night. Okay, do you see that to take the derivative of an ln problem? Okay, u prime u. This is my u. Okay, I'm going to take the derivative of this, put it on top. Wait, I hear something. Wait, isn't this 1 log? Isn't it 1 log fraction? And 1 log fraction equals what? 2 log subtraction. Okay, so you can actually rewrite this as 2 log. And guys, the first log is just this whole numerator. So you put that together first, okay? And it's subtraction. Okay, so 1 log fraction equals 2 log subtraction. But do you see this right here? Yeah, this is 1 log multiplication, which is 2 log what? Summation. Okay, and there's one other thing I'd like to do with this problem, if you guys are okay with it. Do you see one more log property that we can use? Yeah, it'll help you. It'll save you some time if you get rid of this exponent and move it to the front of the log. Now, you can't bring it to the front of the whole problem, just the front of the log expression that you were working with. Okay, so cross out those exponents. You don't need them anymore. Move it to the very front of the log. Okay, and so then what do you get when you do this? you get a new log expression that's exactly equal to what you had before. But make sure you understand, we haven't zipped our pants yet. You guys good? We haven't done any calculus, okay? We feel like we have because we're so tired now, okay? But we haven't. So what you want to do is take the derivative of this. So this is y. I'm going to get y prime. And guys, you thought you got to do one problem, but oh boy, oh boy, oh boy, look at this. You get to do 3. Oh boy, oh boy, oh boy. I'm so excited. Here we go. The first one, we're going to take u prime over u. Are you ready? 5 over 5x plus 6. You see how easy this is once I get it into this format, all right? This 6, guys, is just going to carry down because it's just a coefficient. So 6 times what? 1 over x plus 8, okay? And then finally, the 2, the negative 2, is just going to carry down, multiplied by what? Now, be careful. What's the derivative of 1 minus 2x? It's negative 2. So negative 2 over 1 minus 2x. So if I simplified this, this would be 5 over 5x plus 6 plus 6 over x plus 8. But negative 2 times negative 2, make sure you understand this is over 1, right? Negative 2 times negative 2 is going to give you positive 4 over 1 minus 2x. Okay? What other questions do you guys have from homework? Do you guys see how nice this problem is? Actually, I would go home and do it a couple of times without looking, see if you get the right answer. It will not only make you feel better, but it'll prepare you for the test. Okay? All right, what other questions? Yes, Emily? Yes, number 3 you said? Okay, guys, we're looking at the homework for tonight. Number 3. I've got a pile of papers here. I don't even know what's left and right. Okay, I don't think I have it. I don't think I have your homework, sorry. What is number 3? Okay, oh, e to the square root of x. Are you taking the derivative of that? Okay, you want to rewrite it to e to the x raised to the 1/2. Okay, then this is going to be equal to, ooh, that's not equal to this, but if this is y, y prime is going to be equal to, first, you just copy it. Okay, then you multiply by the derivative of x to the 1/2. So what's the derivative of x to the 1/2? It's, yeah, well, it's 1/2 times 1, right, power rule. 1/2 x to the negative 1/2. Do you see that? Because if you're at 1/2 on the number line and you move left by 1, now you're at negative 1/2. So this is your answer. This is a little bit ugly. If I were to change this back, this would be e to the square root of x. You'd change that back. This would be 1 over 2x to the 1/2. Do you guys see that? Okay, but x to the 1/2 is really what? Square root of x. Okay, so if I were to simplify this, or if you were to find this on a multiple choice, more than likely you would see one of these bottom ones. Okay, then the 1/2. They might leave it as 1/2. Okay, any other questions on last night's homework or tonight's homework? Okay, I'm going to walk around. Please have your homework from last night out. I'll go ahead and check that, and then you guys should be working on the homework for tonight. The homework for tonight should move pretty fast. If it's not, then you probably just need more practice. Those of you guys online, do you guys need any help with homework?
You number 9.
Number 9, okay. From last night, right?
No, from today's.
Oh, from today. Whoa, you guys are way ahead. Okay, let's look at number 9 for today. Travis, can I see what your number 9 is? Number 9 is the second derivative of f of x equals 3 plus 2x. Is that negative 3x? Okay. Okay. Is this right, guys? Okay. So we're going to take the first derivative of this. This is going to be product rule. Okay. So it'll be the derivative of the first, which is just 2, times the second, which I just copied, plus the derivative of the second. Okay, the derivative of this, you see, would be e to the negative 3x times the derivative of your exponent, which is negative 3. And then you need to make sure you multiply back by the first. So derivative of the first times the second plus derivative of the second times the first. Let me go ahead and reduce this. This is e to the negative 3x minus 3 e to the negative 3x times 3 plus 2x. I don't know if this will help, but I'm going to go ahead and do it. I'm going to go ahead and distribute this, okay? Because I have to take the derivative again. So if I distribute this, I get minus 9 e to the negative 3x minus 6x e to the negative 3x. You guys with me so far? Okay. Let's do, wait, where did this x come from? Oh, it should be negative 3x up here. Okay, everybody good so far? Is there anything that I can combine here, make things a little bit easier? Yeah, I think these first two terms combine. So it's negative 7 e to the negative 3x minus 6x e to the negative 3x. Now that's f prime. And now I'm going to take the derivative again. Okay, but it's a little bit, like if I had left it up here, that might have been more work. But now I take the derivative again. The derivative of this is just two derivatives subtracted, basically. Okay, I'm going to change this to plus minus. That's going to help me take the derivative. So this will be, the derivative of this would be negative 7 is a scalar. I just pull it to the front, right? It doesn't have an x. The derivative of e to the negative 3x is e to the negative 3x times negative 3. All right, I'm done with the first term. Okay, the second term, it really helps you if you change this to plus minus, because this becomes negative 6x times e to the negative 3x. So that will just be the derivative of the first times the second plus the derivative of the second, which would be e to the negative 3x times, okay, I'm running out of room. Let me pull this to the left. Okay, so e to the negative 3x times the derivative of your u, the derivative of your exponent, okay? And then remember, this is product rule. So the derivative of the first times the second plus the derivative of the second, which is this whole thing. And don't forget to multiply by the first. When I made this a negative 6x, it was better than leaving a negative and having to distribute when I was done. Okay, that's my opinion anyway. Okay, right here, I'm going to combine negative 7 and negative 3. I cannot multiply across this plus sign, but I can multiply to the left of this plus sign. So that's going to be 21 e to the negative 3x. Right here, I'll just have negative 6e to the negative 3x. And then right here, I can multiply the negative 3 and the negative 6. So do you guys see that's positive 18, right? So positive 18 x e to the negative 3x. I'm going to look for something to see if I can combine anything. Yeah, these two both just have e to the negative 3x. The problem is I don't know what 21 minus 6 is. Is it 15? Okay, so it's 15 e to the negative 3x plus 18x e to the negative 3x, and I am done. All right, guys, check my work, make sure I didn't make any silly mistakes. What other questions do you guys have? Yes.
7.
Number 7?
Yeah, for number 7, for the key, you showed that the signs canceled out, and I'm confused.
Oh, okay.
Because
let me look at number 7. How about we just do all your homework? No, that was rhetorical. Let's see. That was a joke, actually. Okay, here we go. The derivative of this would be, let's see. The derivative is, okay, do you see there are actually two things going on here, right? E to the x and sine x plus cosine x. So it's going to be product rule. It's going to be the derivative of the first times the second plus the derivative of the second. Now this is going to get a little hairy, but the derivative of the second will be the derivative of sine x plus cosine x. The derivative of sine x is cosine x, right? But the derivative of cosine is negative sine x. So it's plus negative sine x. And then derivative of the first times the second plus derivative of the second times the first. All right. So that's what I have. And so did I try to combine this, Araya? Is that what you're saying? Maybe I distributed this here. So then that gives me e to the x sine x plus e to the x cosine x. And if I distribute this here, okay, that would be plus e to the x cosine x minus e to the x sine x. Okay. Oh, check this out. Oh, you guys see this? E to the x sine x and e to the x sine x. Do you see they subtract out, right? So all I have is 2 of these left. And so I have 2 ex cosine x. Is that